Hi, in today's video we'll talk about wireless communication between microprocessors. In this video I'll show you how you can use Atmega8 microprocessor, chip transmitting and receiving model Chinese production, and a few additional gadgets to later use in some interesting projects. Please take a seat and enjoy this video. I will not talk about the advantages and the disadvantages of wired and wireless communication because everyone has a mind of his or her own here. Because I respect your and mine time, let's get straight to the point. What I have here in front of me is a transmitter and receiver, thanks to we can realize simple wireless communication. Nowadays, models such like those ones are very popular among electronics hobbyists and DIYers and can be used with almost all microcontrollers in a wide range of applications requiring wireless radio control. The usage of these models in combination with Arduino is very popular on the internet. But in this video and in the other videos, I'll focus on various types of models that will work with what I'll call pure AVR, mostly Atmega8, 16 or 32, depending on what I'll have on hand. 433 MHz wireless models, which is the operating frequency, can be used only in pairs and only in so-called simplex communication way. This means that the transmitter can only send information and the receiver can only receive it. So you can only send data from A to B, but not from B to A. The transmitter can be powered from 3 up to 12 voltage power supply range. Such a wide voltage range for the transmitter allows you to adjust its power, which, as you can guess, allows you to work over longer distances. It's not a complicated construction, as you can see over here. On the board we can find 3 pins. Let's focus, yes, okay. We can find 3 pins, and looking from the left, it's data pin. The middle one is for power, and the last one is ground. And there's also a place for an antenna. You can see it over here. It's also written. That needs to be soldered. I personally soldered a wire about 20 centimeters long on one of the models, which actually allowed to increase the transmission range as expected. I was able to test this solution. Without antenna, we are able to achieve a distance about 2 up 3 meters, and after soldering the antenna, I was able to communicate between rooms with no problems. Now we'll talk a little about the receiver. Here you are. It's powered from a voltage of 5 volts, and it is a rigid value in contrast to a transmitter, as you remember. 5 volts is standard for our microcontrollers, so there are no problems with it. given that the transmitter will also survive a close encounter with this voltage. The transmitter has 4 pins, and yes, looking from the left, we can see ground, 2 pins of data pins. These middle 2 pins are connected on a circuit board, so if someone forgot to connect 2 data pins on the breadboard, the designers of the circuit board did it for him or her. And last pin, as we can see, as we suppose, is is VCC. In addition, our attention can be focused on something big one in the middle of circuit board. And the question is, what is it? And the answer is, in the middle of the receiver circuit is located frequency calibration potentiometer board. This is an RF circuit, so we need to tune the receiver to the ideal point of the frequency of transmission. So if you have a problem to receive data at the output in your project, so remember, do not toss out, do not throw the receiver into the basket at once. First check that if everything is well connected, and then try to adjust the potentiometer, and if this didn't help, then you may have somewhere in the back of your head thinking that one of the possible scenarios why communication isn't working is the fact that the transmitter or receiver or even both are just a nice looking green circuit boards. So if you are unable to receive the transmitted data, it's possible that the transmission and receiving frequencies are not matched. And please do not forget about it. Remember, and the model, like the transmitter, also has a pin for the antenna, and over here in the left, wait a moment, yes, here in the left corner you should solder the antenna. Approaching to the practical part, we must firstly mention about encoders and decoders. And the models cannot function alone because the signal requires some kind of encoding before sending and decoding after receiving. Therefore, these models must be used with encoder and decoder. The easiest way is to use the HT12E encoder and HT12D decoder. I've experienced with them before. I'll try to show you them. Yeah, this is encoder and this is decoder. You can recognize them with last letter D for decoder and E for encoder. And what's important? It's important to stick to the instruction that you can find in datasheets, especially the issues regarding resistors between pins 15 and 16 that are used to connect the resistors to the internal oscillator. I'll show you now those pins. Wait a moment, please. Okay. Yeah, and here's pin 15 and here's pin 16. And the same situation for for decoder. And OSC1 pin is the oscillator input pin, and OSC2 is the oscillator output pin. For the decoder, it should be the value of resistor should be about 1 mega ohm. As you will see in a moment, I put 3 resistors in parallel that as result give about 1.5 mega ohm. But you should be smarter and less lazy than me. Buy a resistor 1 mega ohm in the store and put it in place as in datasheet is written. And for decoder, the resistor value is around 50 kilo ohms. I used 47 kilo ohms. Yeah. Okay, I think the theory is already behind us, so let's go to the next part. Okay, hello once again after a short pause. In this part we will write simple code to our project. Our project consists of 2 microcontrollers that separately control transmitter and receiver. In transmitter part we have 3 buttons that will force a specific state which will be signaled both transmitter and receiver part by switching on or switching off specific LEDs diodes. Yeah, okay. Now let's start to write a code. And what do we need? Well, we need 2 outputs for LEDs diodes, 3 inputs for buttons, and 4 outputs, what's very important, that the sum will give us an address that through transmitter will be transmitted up to receiver part. Okay, then as I told, we need 3 pins for buttons. You can change this value. We need 3 pins for buttons. So let's declare 3 inputs for buttons, and let's declare register DDR B and its 3 pins. I've chosen register DDR-B and its 3 pins as input, and I'd like to also mention that if something isn't clear for you, then I recommend for you some kind of simple AVR course. There are a huge number of them in the internet, so you find it very easy. Okay, let's declare 3 pins as inputs. In next register we declare as outputs 2 LEDs diodes, 4 2 LEDs diodes. And in case of last register as outputs, what is very important, we declare 4 outputs that operating between low and high state and giving the state on encoder, they give us one address which will be encoded in encoder and through transmitter will be sent up to receiver part. Okay, here we set a state on every single pin on port B, port C and port D. Okay, now let's move to the part of checking the state on buttons pins and check if button is pressed. As I previously told, if you don't know why this instruction looks like looks and you have no idea what's going on here, then I recommend our internet course. Of course, maybe in the future there would have been possibility to record simple FR calls, but on this channel I like to share and focus, and share with my projects and ideas about nice projects that you can do on your own, and you have some basic knowledge about FR programming. Okay, code is already written. As you can see, it's not very complicated. For transmitter part, it's everything. Yeah, as you can see, port C register. Oh, sorry, here's a little mistake. As you can see, port C register is used to control the state of LED's diode. That allow us check if button is pressed. Okay, then I'll prepare a new project, clean project for receiver part, and I'll come back soon. See you in next part. Hello once again. As you can see, new project is already ready. We can start write the code for receiver's part. But firstly, I'd like to mention, because I've not probably done it for, in transmitter part, in if clause, there's declared register port D with such strange number. It's a hexadecimal number, and this is address. Its value that will be sent up to the encoder, then to transmitter, which send it up to receiver part. Okay, that's all. So I think now we can come back to our code writing. And similarly, like before, we have to declare registers and pins of input and output. In this case, we have available two LEDs diode, and we declare pins for them as output. And similarly, like before, 4 pins for received address. However, unlike the previous situation, we have to declare them as input, because we will receive address from decoder and send them up to microcontroller pins. Okay, now I'll do simple LED blinking to check that everything is well connected and LED work correctly. Okay, now let's move, I suppose, to the most important thing in this code. We have to check received address. That means we have to use in if clause and between pin B register and mask. If the result is different from 0, then we have to execute code inside if clause. Mask is the address received from transmitter and declared previously in register port D of transmitter part. Okay, that's all. It's not very complicated. Uh, I would even say it's trivial. In proper if clauses, we check address that has been received, of course previously declared in the transmitter part, and if yes, we set right combination of LEDs diodes. Okay, due to I think it's all, and the program compiles. Oh yes, exactly. We can move to the last part and check the project and see the results. Let's go. Okay, here's the last part of the project. Here's the transmitting part, and here is receiving part. These models with other devices like microcontrollers are already connected, frequencies also already matched. Yeah, then there's nothing left, only check the results and check if everything's fine. For this purpose, I'll connect the power supply from the 20 volts AC/DC adapter, which is already connected. The voltage is stabilizing using 5-volt stabilizer, and thanks to it, all logic here is 5 volts. Yeah, without extending, let's check. Okay. Yeah, as we can see, till now everything seems good. LEDs in transmitting part are switched on, LED diodes in receiving part were blinking and now are switched off, which also suits to our program that was written before. And now let's check our wireless communication using 3 switches mounted on breadboard. As we've told before, we've got 3 switches. The first one should allow us to switch on only right LED diode in receiver part. The second one only left diode in the receiver's part. And the third one should allow us to switch on both diodes. So let's check it. First switch. Yeah, it's working. I'm pressing the button again and again, and everything suits to our presumptions. Yeah, now let's check the second button. Yeah, it works wonderful. The second diode illuminate and the first one is switched off. And the last button should allow us to switch on both LEDs, and here you are. Everything is working. Yeah, as you can see, we can try various combinations that allow us switch on various combinations of LEDs. Well, I think that's all. Thanks for watching. I recommend to build this project on your own breadboard, and of course expand it using other devices and writing more advanced code than me. Yes, wireless communication is a very important thing in our life, and we can meet it on every step of our life. Yeah, PCB board diagram is below in description section. Code is available in the video. So once again, thanks for watching and see you in next video. Bye!